So whenever you start, come on, phones away. You just had lunch. You just had an hour of, relaxing. So I just want you for like 40, 50 minutes and that's it. So the very first thing you ever study, whenever you study physics in general, is kinematics. Okay. By the way, the only exception to that is that some teachers in high schools, they usually don't start the first unit as kinematics. They start as waves and sound. And the only reason they do that is because waves and sound seems to be its complete independent unit of all the other physics units. So they're like, let's just do it now. And then we start legit kinematics, forces, all of that. I don't like that. I like to start, the first thing with kinematics, okay? In your Nelson textbook, it covers chapters 1 and 2. However, we're mostly going to be covering chapter 1. Chapter 2 of the Nelson textbook, we're just going to skim through it. Most of the material we need is actually from chapters number 1, chapter number 1. Okay, so kinematics is the study of motion. Every time you hear the word kinematics, you know that the motion somehow is what is involved. Okay, um, the root of the word, which is Latin for kin, is Latin for motion. Every single thing that starts with kin means motion. How many people know kinesiology? Has anyone have ever heard of the degree kinesiology? Yes, you might actually. How many people know Hanzala? Hanzala? Yes. His older brother, who I taught 2 years ago in grade 12 physics, is actually doing second year kinesiology at Western right now. This is, I like to call kinesiology the degree for the jocks and, the sports people. Basically, kinesiology is the degree of study of human movement. You study, a lot about the joints, the muscles. They actually take certain courses where they literally have to work out and get, for example, like assessed, like they actually put them on treadmills with the oxygen mask. It's basically like a degree for mostly athletes. Uh, Possible career paths that lead after it is like anything. Actually, you can go to med school and become an orthopedic surgeon or a sports medicine specialist. You can become all kinds of like joint specialists, like physiotherapist, conditioning coach for like sorry, sports team and so on. Okay, and the word kinetic, which is related to motion. Every time you hear the word kinetic, you know you're talking about motion. Okay. Kinemat. It's important to know this though. Kinematics is only concerned with describing how the motion looks like. Okay, it does not care at all about why the motion happens the way it does, or why does it stop happening. Okay, so for example, if I ask you right now, you're standing in the parking lot and a car slows down. Why does it slow down? You cannot actually answer that using what? Using what? You cannot answer using kinematics. What do you need to answer questions like why did it speed up? Why did it slow down? Why did it not even move in the first place? You need things like what? You need things like forces, which is I guess in 3 weeks roughly, and energy and work, which is the unit after that. What kind of questions are we gonna be dealing with in this unit for the next 2 to 3 weeks? We're gonna be dealing a question be dealing with a question with questions like the object speeds up, slows down, how far it travels, to what speed it goes, from what speed it started, how far did it travel, how long did it take to travel a certain distance. You are only describing the motion. You are not describing why the motion is happening the way it is. Okay. So as far as you're concerned, every car outside right now is just a box. You really have no idea what the internal mechanism of it is. You're just describing how it looks like in front of you, and that's it. Okay. All right. So the very first thing we have to start with when you actually discuss kinematics, the main quantity is called position. Okay, it's called position. Okay, so position is, and by the way, those numbers, everyone, numbers in parentheses or brackets after the titles are basically the page numbers in the Nelson textbook, in case you want to reference to it. So position is the root of all quantities in kinematics. Okay, you cannot understand kinematics unless you start on a position first. Here's the good news. I will teach you position today, and then we will not talk about position for the end of the course. We kind of have to build from it, but then we are mostly gonna be interested in things that actually are derived or created from it. Okay, so let's describe. Okay, everyone, let's describe the position of the door. That's the class main door, obviously. Those are not main doors. That's the class main door. Ugh. So main door. Um, okay, and let's assume that I know you're all facing different directions. Look at Bashar is facing this way, Christy is pointing this way, Mason is facing this way. But let's assume that to all of us, we will assume that this direction is what? North. By the way, you have to agree on a universal direction from the beginning. Otherwise, you cannot really reference what directions in any physics or math problem. Okay, so here's my question to you. Do you really think that the position of the door, so for example, Mu'min, is the same as the position of the door from Christian is the same as the position door of Ibrahim? If I ask you all to get up right now, don't do it. Get up and move towards the door. Are you all going to move exactly the same distance? Are you all going to move exactly in the same direction? Which means you're all positioned differently according to the door, or the door is positioned differently according to each one of you. Okay, so let's actually which means we technically have, I think I have 20 students. We have 20 potentially different ways of saying where the door is from each and every one of you. Okay, so the position of the door is okay. Let's see one way. Everyone, let's say I want to eyes on me. Everyone, let's say I want to describe the position of the door from me here. Okay. For example, if Uday is telling me how to go to the door, he has to tell me how many pieces of information? Two. What's the first one usually? He tells me what? What am I doing? Turning. I'm turning. I'm basically changing my what? My direction, right? Okay. Uday is telling me turn, Mr. Ramadan. I'm like, okay. And then he tells me stop. Okay, that's good. Then what does he have to tell me? Do you just tell me walk, or do you have to tell me a certain number? What do you call the separation between two objects in space? Distance. Thank you. Exactly. So that means what? If I'm here and you're telling me where the door is, you're going to have to tell me two things: how far it is and how many degrees do I have to tilt my neck to see it before I set into motion. Right? Make sense? Is there any other thing you need to tell me to make it for me to beeline it to the door? No, I just need to know how far and which way. So let's just estimate. How far am I? Obviously, this would be the furthest end because diagonal is like that. So how far would that be? I know, you know what? I always like to think of it this way. I love estimation. Um, I'm 5'9", so let's say 6. I'm not 6, but 5'9". How many Mr. Ramadans do you need to place on the ground all the way to go here? So let's say, for example, you need about 6 of me or 7. So about 7 times 7 times 6 feet. Let's about say 40 feet. Now my question is, which way am I facing now? Come on, which way did we say this is? No, no. Which way did we say that all of us are facing that way? North. We said that this way to all of us is north. Okay? If I turn this way, which way am I turning my neck? By the way, this is north, and I'm turning my neck this way. Exactly. My right then would be what? Would be east. Okay? Obviously, you don't just tell me turn your neck. You have to tell me when you turn, how do you measure angles using what? Come on, in math, how do you measure angles? And please don't think of grade 12 calculus or functions, because there are two ways to measure angles. What's the easy way to measure angles? Come on, people. You said it. I think I heard someone say it. Degrees. Thank you. You have to tell me how many degrees I have to tilt my head, right? So the first thing, you tell me how far. And the second thing, you tell me how many degrees. Or you can tell me how many degrees first and then how far. The usual thing is that you tell me how far first. Okay? So let's say, for example, everyone, I'm going to say what? Right here. Let's say 40 feet. Hold on, I can't see the 40. Go ahead. 40 feet. Okay. Now, I was facing north and I turned what? East. I'm going to just say northeast. How come I'm not saying an angle? Does anyone know what does it mean? What angle is always assumed when you say northeast, southwest, southeast, northwest? 45 degrees. If the angle is not mentioned, it means it's exactly in between this and that, which is exactly what? 45 degrees. Perfect. Any other angle has got to be specified. So we're going to say 40 feet. Where's the thing? 40 feet northeast. Go ahead, northeast. But you have to tell me where from. Go ahead, from. I guess we can call this far corner. Sure, far corner. Far corner. Okay. Guess what? You told me the amount or the length, and you told me the direction. Thank you. And you kind of told me also from where. Okay. Go ahead, copy that down. Now I'm going to actually change my position somewhere near Bradley here. Here. Can someone now tell me what could be my distance? By the way, that thing was 40. So how much do you think this is? By the way, we're not sticklers for exact here. What do you think? In a way, I'm asking you how wide is the classroom? Like how far is that wall from this wall? By the way, could it be 40? No, because that violates the Pythagorean theorem. The Pythagorean theorem tells you that the diagonal or the hypotenuse is the longest one. So this guy has got to be shorter. Let's say 20. But what am I facing exactly now? Like if I want to go from here to the door, all I have to go is to go to which direction? Do I need to make absolutely any deviation from it? No. So go ahead. My second one, by the way, I don't care about what just appeared 15 feet north. That was from like years ago at Weeble. I should actually change that. We are just going to go with 40 feet northeast from far corner. Okay, second one. We're going to say what? 20 feet, 20 feet north, capital N, from what? From, I guess, what can we call this? We can call this file cabinet. File cabinet. From file cabinet. Yeah, more question for you. Do you really think it's like there's a point of doing more examples, or do they all more or less follow the same idea? Exactly. I mean, technically, there's so many ways, but it has to apply to what every single one of you. So you know what? These two are general, but the specific ones will have to do with moment, with Mason, with Selma, and so on. So the third choice is any answer that applies only to you. Go ahead. Whatever answer that only applies to you. Okay? Yes. Oh my God. Do we have any extras? Yes. I just didn't know where people were sitting. Sorry. Okay. All right. So from these statements, let's define what position is. Now we're going to actually define. Okay. So the definition of position, everyone, is basically just this. Go ahead. The position of any object is the location of an object, okay, according to what? To a specific point in space, like the far corner or the file cabinet, okay? I like to call, or not I like, it is called that specific point in space from which you start moving or measuring things is called the origin. How many people have heard the word origin before? Where do you usually hear it? In what course? In math course. And what is it? It's the center of the universe. It's the intersection point between the x and the y axes. Okay. Some people like to call it the reference point, which kind of is describing what the point is. It is the point from which you reference everything. Okay. So it's the location of an object according to a specific point in space. Okay. Let's go to the next slide. Okay. So it seems examples of any position always look something like this. The desk is 4 feet to my left. 4 feet, yes, 4 feet to my left. Another example. This is kind of like sniper lingo. The target is 300 yards. By the way, a yard is 3 feet or 90 centimeters. At 3 o'clock, what does that mean? If something is situated at 3 o'clock, what does that mean? Where's 3 o'clock to you? I guess just exactly, yes. It's to your 12 o'clock. It's got like a clock in front of you. 12 o'clock is forward. Yeah. 6 o'clock, 9 o'clock, 12 o'clock again. Okay? So the target is 300 yards at 3 o'clock. How many pieces of information is given in each one of those statements? Two, a number with a unit, obviously, because physics needs units, a number with a unit, and a direction, a number with a unit and direction. So that means we notice the position of an object is always specified using two pieces of information. How far the object is from the origin, and which way do you have to go to actually make it to that object. Okay, so how far and which way. Okay, does anyone know another word for or another synonym for the word amount or quantity in math or physics? Come on, phones away, unless you're looking for the synonym. Does anyone know another word for quantity or amount? Give me a hint. It's an important word in math or physics. That's why I really need you to start using it with you. Say again? It's okay. So mass itself is correct, but it only applies to what? To like how heavy an object is. But in general, what do you call the size of a what? Of, for example, a number or a quantity in math or physics? If someone told, if you lost some money in the stock market, someone could ask you, how much did you lose? Or they could ask you, what is the what of your loss? Starts with M. All right, I'll give you more hints. MAG, magnitude. Thank you. Yes, perfect. Magnitude in all of math or physics is basically just the what? The numerical value, the size of the value, the size of the number, and direction. So this one, the how far, everyone, how far is the magnitude, and which way is obviously the what? The way of pointing or direction. What do you call a physical quantity that is specified using magnitude and direction? Does anyone know the last math course you take in high school? Calculus and vectors. Thank you. Exactly. Anything that has a length and a direction is called a vector. Okay? So because position must be specified or given as information using magnitude and direction, it is an example of what is known as a vector. Vectors are very, very extremely important in not just math or physics, in all of scientific knowledge. Um, Actually, if anyone here is hoping to, major in engineering, whether in university or college, in any way, shape, or form, half of the math you will take somehow will be what will be centered around vectors. It's important not just to tell me the amount, but you have got to tell me the direction as well. Which means what, everyone? It means if I ever ask you for a vector, like to tell me what a vector is, and you only tell me one of those two things, either or, not both, either or, you are not getting full marks for your final answer. You have to lose 50% because you did not tell me half of the information I need. Okay? Okay, next slide. Hey, by the way, we're gonna finish early today, so I'll go back. Don't worry, you're good. Physical symbol. Everyone, pencils down. I just want to make sure that I get this through. Okay, listen up. Many people think, listen up. Many people think when I ask them for a physical symbol, they say, "Oh, easy, meters or centimeters." Is meters and centimeters a physical symbol? No. What is it? What's meters and centimeters and okay, they measure distance. Good, but what are they? Kilograms and feet and inches. What do you call these things? What did we do on Friday? What conversion? Unit. Those are called units. Do you see what I mean? A unit is what you use to what to measure something, or a unit is what you put at the end of a number. How many people? Everyone, raise your hand. I'll raise my hand for sure because I used to do it. How many people lost marks in math courses because you always forgot to put the unit at the end of a math final answer? Yep, and you lose communication marks. Why? Because you're so not used to what you're just math to you is just a number. By the way, just so you know, you will never have that trouble in my course. Why? I will never give you a question unless it says, for example, what is the mass, in brackets, in kilograms of the block that you are pushing? Or what is the height in meters of the building that you dropped the egg from? Do you see what I mean? I'm always going to remind you to put the unit in and to tell you what unit I want your final answer to be, in case there's a unit conversion that needs to be done. Okay? But my point is, that's a unit. Who knows what a physical symbol is? Or you know what? You can call it a mathematical symbol. But what's a symbol? Centimeters and kilometers are units. What's a symbol? Okay, I'll give you a hint. Who knows the Pythagorean theorem? In not in words, in the equation form. Uday. Say again. 1 second. Hmm? There are two ways to say it. Depends on how you want to start or what you're trying to solve for. Are you trying to solve for the hypotenuse or one of the two perpendicular? Either way, both are correct. Which one do you want to suggest? Okay, C squared. Now, question for you, everyone. The A and the B and the C, are they units? Are those units? No, what are examples of units? Centimeters, kilometers, inches, feet, and so on. Those are not units, which means they have to be what? Or mathematical symbols. Doesn't matter, just symbols. What do they represent? Can someone tell me what does the C represent in the Pythagorean theorem? By the way, we're going to use the Pythagorean theorem a lot in this course, starting from tomorrow. Hmm. C is the what? Length of the what? How about B? Sorry, one of the what? Angles don't have length. Angles have what? Opening or measure. Okay, so it's the length of the what? So this is one side, whichever one, which means this has to be the what? Thank you, the other side. Those three things are what? And if I want to put them in units, I could say what? Centimeters. Obviously, the units have to be the same. Anything, but they have to be the same. Perfect. So the question is, what's the mathematical or physical symbol of this? Sorry, what are we doing? Position. Well, you probably haven't seen it before, ladies and gentlemen. It's this. Go ahead. It's a lowercase d with a what on top, which is very important. What is this? An arrow or exactly, thank you. It's an arrowhead. Every time you are dealing with a vector, you have got to put what on top of the symbol? You have to put a what? You have got to put an arrowhead. You cannot, when Mr. Shivers taught you vectors, for example, every time he asked you for a vector and you just wrote, for example, the lowercase d and forgot this, I don't know how lenient he was, but many teachers would what? Take a communication mark off, because a vector needs what on top of its symbol? What? An arrow, a short arrowhead. Okay, this is super, super important. Okay, so everyone, couple of things about this symbol. Number one, the little arrow above the symbol is just there to indicate that we are dealing with a what? That's it. There is no, everyone, there is no other meaning or point of that little arrowhead except to tell you you are in vector land. That's it. Many people think that this vector is the actual what? Is the actual direction of the physical vector that you're trying to report or measure or sketch. Let me tell you a small story. Everyone, listen up. Been teaching for 12 years. My first time ever teaching 3U physics was in September 2010. Okay, 12 years ago. So I'm teaching. This was my first lesson. This is always my first lesson. So I'm teaching, and I'm teaching them about this as a symbol and everything. And then I realized that I did not rehearse my lesson that well. That's the thing about teaching. Teaching is acting. You have to rehearse. The problem is, okay, I'll give you one thing. Do you remember where I finished my high school? I did not finish here. Where did I finish? Saudi Arabia. What language is spoken there? Arabic. Does anyone know how Arabic is written? Arabic is a Semitic language, like Hebrew, for example. Uh, well, that's backward to it. So I guess right to left. So I actually did math and physics in legit Arabic for 12 years solid. Okay. Over there, the D, for example, the symbol for it is called dal. Some people might know it, those who speak Arabic. Well, guess what? I did 2 years of vectors, grade 11 and 12, making my vector go this way. The only reason that the vector goes left to right in here is because we're speaking what? That's it, and it goes left to right. I did years of this. Here's the thing. That arrow has nothing to do with the physicality of the vector itself. So I taught that day, and then I gave him some homework. Back then, I used to give homework and check it. They show up the next day, and I'm seeing things like this in their homework solution. I'm seeing things like this. Hold on, this is not even the worst part. I'm seeing something like this. I, I guess the vector was pointing straight what? Straight, physically up. Okay? This is nothing. There was a kid, oh, I still feel bad to this day. Apparently, the direction of the vector was 30 degrees above the ground. He wrote this with a pencil. So obviously, I'm exaggerating the size. He did the D, he did like this, and then he did a dashed line, and he, with a protractor, measured 30 degrees and wrote in very small handwriting 30 degrees. And now I'm looking like, why are you doing this? He's like, because that's what you did yesterday. And then I realized, you know what happened the day before? I gave them all the examples I taught them, like all the examples I used to teach them. All of them pointed which way? Pointed this way. So what kind of logical connections did they make during the lesson? That this direction also represents the what? The actual direction of the vector itself. So if the vector is going this way, I have to use this. If the direction is going up, I have to use this. If the direction is going 30 degrees above the ground or whatever, I have to use this. Is that the case? Is that the case for us? No. This is just a what? An indication that you're dealing with what? This has nothing to do with the real direction of the what? Come on. Of the what? Of the vector. So obviously the question now is, so Mr. Ramadan, how am I going to actually then tell you the actual direction of the vector? Guess what? That exercise is coming up right now. I just needed to make sure that you know that the direction of the little arrow has nothing to do with the actual direction of the vector itself. It is just a standard indicator that we are dealing with a vector. All right? So that basically, in other words, everyone, this is wrong as far as doing physics and English is concerned, and this is wrong as well. So go ahead. Any other direction other than left to right is not acceptable. All right. Physical unit. What physical units are possible when you talk about position? What unit did we use to describe the position from there to there? Do you remember what unit we used? We used feet. Is that the only thing we used? Oh my God, no. There's a collection of things. The physical unit of position is any unit that measures length, which means examples include kilometers, feet, yards, inches, atomic units for very small, separations in the nucleus, light years for astrophysics. Yes, again. Knots, yes, exactly. For the nautical, yes, the nautical mile actually is a speed. You're right. Knots is basically a distance. So there's so much. Well, guess what? It can't be just as free flowing like that. I mean, it's a good thing we have a lot of units, right? But we have got to be standard. What does that mean? In the mid 80s, I guess. Yeah, I think no, late 80s. Scientists and engineers have had to agree on what we call, everyone, a standard system of units. What does that mean? It means if we are corresponding together, I can just do things in kilometers and Jenna does things in feet. No, 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 no. We have got to all. You can do things in feet. I can do things in inches. But guess what? If we're corresponding, we have got to standardize them to one thing. Does anyone know what's the standard unit of length in all of physics? Actually, in all of science. It's called the S, by the way, just for a second. It's called the SI system. SI for French, international system. But in French, what happens? You always put the adjective after the word. You say system international. So that's called SI because the agreement for these standard units was signed in Paris. So does anyone know what has been chosen as the standard unit of length or distance in physics? I'll give you a hint. It's not one of these. Any guesses? Mason? The meter. Thank you. The meter, everyone. The meter has been chosen as the what? As the unit of reference. So for example, now, if people at NASA, for example, are communicating something about satellite with people from ESA, European Space Agency, they have got to communicate everything in what unit? In meters. Okay. By the way, does anyone know what has been chosen as the standard unit of mass? So meter for distance. What about mass? Like how heavy something is? Kilograms. Nice. How about time? No one knows. No. Like what unit? Is it the hour? Is it the minute? Is it the day? No. Second. Seconds has been chosen as the what? As the and so on and so forth. Okay. All right. Hey, yeah. What's up? You switch here? Okay. Yeah. Anyway. Okay. It is the meter. Why am I having these two pictures? Because we have two spellings. We have the American meter with ER, and we have the English meter with RE. Hey, he just became king. However, we are physics folks, right? We don't like to write big words. We don't even care how meter is spelled. What's the symbol for meter? Uppercase or lowercase? Lowercase. By the way, everyone, most units are abbreviated or shorthanded, lowercase. So go ahead, lowercase m. I barely any units are uppercase. Most units are lowercase. Kilograms is lowercase. Seconds is lowercase, and so on and so forth. Okay, we don't care about spelling. We just care about how the unit is actually written as a symbol. Okay, all right. Everyone, let's do an example. So pencils down while I guide you through the example. Okay, just everyone, eyes on the board. Hamza, do you have notes? Those are yours or no? Those are yours? Or no? Are they extra? Like yeah, you're good. Okay, consider the following. Who can tell me what not to scale means? What's a not to scale diagram? Well, you either explain that to me or explain to me what's a to scale diagram means. Anyone knows? This is important. Come on, people. A not to scale means what? The diagram might have a distance that looks smaller, but it actually has a what? Has a bigger magnitude as a distance. It's just a rough diagram that we just need to get through. Okay? So here is everyone. Here is a. Sorry, let's just go through. Yes. So what is the meaning of this X right here? What do you think I actually called it? Origin. Whenever usually I put an X on any diagram, 2D or 1D, by the way, those are all 1D problems, it means origin. Okay? By the way, question for you. What if I don't indicate the origin? Can you choose any point of your choosing to be the origin? What do you think? If I don't tell you that I chose this to be the origin, can you then choose the origin to be any point you want, even if it's actually one of those three objects? Yes. Actually, yes. As long as you choose it and you show me what it is, you're fine. Do you see what I mean? I have to see what you chose to build everything from your own reference. But if I choose it, that's it. I mean, you're kind of stuck. So you just go with what I chose. Okay? So the origin is here, like the 0 point, I guess, or the center of the universe. And this distance is 330, I believe. Yeah. This one is 530, and this one is 680. Okay, everyone. Here. Oh, okay. What did I just choose here as well? Or what did I just indicate? What did I indicate? Say again. What's it? Direction. Question to everyone. If I chose this to be west and that to be east, what do you think? Is that allowed? Is that permissible? What do you think? Say again? But do you think it's wrong? Do you think, I mean, why do you think I chose east to be here? Because usually, where's east? If you're looking straight forward, it's to your right, exact. If that was north. But in general, does it matter what directions you choose? Absolutely not. I mean, if I stand behind, then technically, where's my west? That way, right? So really, everything is relative. What does relative mean? It depends on you. So please, unless I choose direction, everyone, eyes on me. Unless I choose directions, go ahead, choose whatever you want. You wanna flip these? Full marks. You wanna call it north and south, south and north? Go ahead. You wanna call it this way and that way? You wanna call it positive and what? By the way, we're gonna get so used to the positive and negative, and that's the actual way in college and university they want you to do. Skip directions, use plus minus. It makes things much easier and much easier to calculate and less writing as well. Okay, but for these next few days, we're gonna keep actual legit directions. Okay, so I chose east and west. I just went with the basic choice here. Okay. Oh, I got. Okay. Question one. What is the position of the what? Of the person, you see how I'm always going to give it to you, in meters, for example. What is the position of the person according to? By the way, get used to these four different ways of saying according to. Listen up. You can say according to, you can say as seen by, you can say relative to, or you can say, what's the third one? According to, as seen by, relative to, oh, with respect to. With respect to is someone like Ibrahim, for example. He's used to that way from calculus. With respect, with respect, with respect. Basically, it means as seen by. So here's my question to you. What is the position of the person according to you if you were standing at the origin? All you have to answer is two questions. Number one, how far is the person from the origin? Remember, you always need distance first. How far is the person from the origin? Uday. 330 what? Remember, physics is a unit idea. It has to have a unit. 330. Okay. Which way is the person according to the origin, direction-wise? If you're at the origin and you want to walk to the person, which way are you going to walk? You're going to walk what? Exactly, towards the west. So, ladies and gentlemen, this is, everyone, this is how we represent position or vectors in general in math. Sorry, in physics 11. Ta-da. Done. That's it. By the way, the only thing that you don't need to write here is this subscript. I don't know why I always have it. I guess because I have multiple positions in this problem. Check it out. You gave me how far. You gave me the unit. What kind of brackets did I use? What kind of brackets did we put the W in? Usually in math, there are three kinds of brackets. What do you call this bracket? No, they're all parentheses. But what kind of them? Because there are these ones, and these are square brackets. Everyone, in our course, we do not use round brackets like circular, or I don't care. I don't know what they call them. I call them the curved brackets, like these ones, like the loopy ones. Nope. We use in this course, and grade 12, by the way, we use only what kind of brackets? Square brackets to put directions in. That's it. By the way, a big mistake, people do this. Everyone, check this out. I mean, make as many mistakes as you can now, okay? People do this. Do you see what I mean? Did they still use square brackets? They did. But they put what inside of the square bracket? The whole thing. No. Square brackets are not for the magnitude. Square brackets are only for the what? For which part of the vector? The magnitude or just the direction? Just the direction. Everyone, you cannot do this. You cannot say put square bracket and put everything in. No. The square bracket is only for the direction part. Please. Okay, so let me erase it. 1 second. Oh, say again, sorry. Exact, and we're gonna do more of that in grade 12, but we're still gonna do a little bit of it in grade 11 as well. Okay. All right. Next one. Yes. Just let me finish those. They're almost like the exact same amount of work. Okay. How about this one? What's the position of the house according to the origin, or as seen by the origin? Who would like to feel this one? Raise your hand. Okay, we have Uday. Anyone else? Uday, Jordan. Listen up. Go ahead. Huh? 530 meters, because Jordan basically asked himself, how far is this from that? Is it 530 meters? I want you to go from the origin to the house. So what do I need to do? Exactly. Because look, if you really want to go from here to here, it seems that you have to go this first, and then what? Make sense? Okay. Which direction, though? Which direction do you have to go if you're walking from the origin to the house? East or west? Just everyone, shh. You don't have to guess. Trust me, math and physics are not guessing stuff. Why? Because if you go that way, which direction are you going? There you go. That's it. So, obviously, we can just do without this. Yeah. Higher. Do you need to put the what? You mean this one? Okay, everyone, listen up. So Kristen is asking, do I need to put the statement D equals or just jump to the 860 west? Is that what you're asking? Technically, whenever you actually give me a final answer, it has to be preceded by what? By an equal sign. And since I am asking you for something that does have a physical or mathematical symbol, I just need to make sure that what? You know what? Here's my answer to you. If you ask the math teacher, do I have to write x equals 2? Can I just write 2? What would they say? You have to write x equals 2, right? You cannot just give me a number. You have to tell me a statement. X equals 2, and sometimes x equals 2 centimeters. Okay? Okay, last one. Okay, interesting. Apparently now I am skipping the origin altogether. Where am I starting from apparently? Come on. I'm starting. So technically, my origin now is the building. It's everyone. It's as if this guy does not exist now. So just this. So can someone tell me how far is the building from the car? Raise your hand. How far is the building from the car? Anyone? Ibrahim? How'd you get that? What about the 330? It's Thank you. Is this separate or absorbed in this one? It's overlapped, which means what? Do you need it? No. You can just do this and then pile this guy on it. So what's the final answer, Ibrahim? 1210. My question to you is, my friend, which way? Why east? You're right. Why? Imagine. Exactly. Because to go from here to here, I don't care where I start from. I care which way I traveled. I traveled towards the east. Perfect. So this is the answer. Again, no need for that. Is it making sense now? By the way, is all of this physics? None of this is physics, by the way. We are just getting to learn. No, no, seriously, think about it. This is just, I can't teach you math before I teach you, for example, the language. Same thing. I can't teach you physics before showing you what the statements mean, what's the variable names, how to really talk in physics. Okay? The good news is only just for today or tomorrow, and then we will actually start learning actual physics problems. Okay, last thing for today. Really, last thing for today. Do you think anything in the universe is actually standing still and not moving? Like you might say, okay, Yamur, I might ask you, well, you seem like you're standing still to me, but are you? In the grand scheme of the universe, are you standing still? Heck, the earth is moving and spinning and rotating. So that means what? Every single thing in the universe is what? Is moving. By the way, if they happen to discover the one point in the universe that doesn't move, what do you think they would have discovered? The center of the universe, exactly. Like if everyone, look at me, everyone. If I spin like this, is every point on my body spinning? Yes, except for what? Except for the points that go through the what? The central axis of my body, right? Always the same. If you spin a ball, for example, and you may perfectly spin it without swaying, if it perfectly spins where it is, the only points that do not move are the points that perfectly are central in the ball itself. Okay? Well, guess what? We assume that everything moves in general. So from starting from tomorrow, we will actually talk about what? What if an object moves? It means it goes from where? From a starting position to a what? Ending position. By the way, sometimes those two positions are the same. Sometimes they're what? Question for you, everyone. Have I moved yet? Right now, am I moving? Okay. Did I move? Is my final position the same as my starting position? No, it's not. You can tell this is not the same point in space as that one. What if once I got to here, is my final and starting position now the same? So basically, when things move, they could go away from their starting point or what? Come back. Thank you. Either like a circle or a line like this. Tomorrow, we're going to do things like that. Most of the time, we're going to do things that don't come back, but we could. Okay? Because things will definitely be more interesting, but more complicated. And that's today's lesson. That's all I want to cover. I want to take it easy, kind of like give you a sense of the handouts and the routine and so on and so forth. Okay? That's it.